My name is Ferguson. I'm a research engineer here at NETL. I'm in the thermal sciences team. I work in energy conversion, looking at how to convert energy from one form to another. I'm actually originally from West Virginia. I grew up in Clarksburg, West Virginia, which is just a little ways down the road. From a very early age, I was interested in sort of how things work. I have a sister, and my sister's also an engineer, and we were always taking things apart to kind of understand how they work. But as long as I can remember, I've had a big interest in science. I was born in 1969, right after the moon landing. So as I was growing up, a lot of what you'd see in the news is space and space travel, and that influenced my decision to some degree to go into aerospace engineering. Having sat through a lot of my engineering classes, that helped sort of focus my areas of interest more into thermodynamics and combustion, which is where I work now. Gas turbine engines, like a jet engine that you'd see on an aircraft, are also used for power generation, except they're much larger. Historically, these engines have used a form of combustion called deflagration, and that's how our car works, that's how your stovetop works. So an alternative to deflagration is called detonation. It's a controlled detonation process where we can generate this continuous detonation wave that propagates around inside what we call a combustor, or where we're burning the fuel in the air. This is pretty neat if we think about the conventional combustion wave. That wave will propagate at most, say, 100 meters per second. With a detonation wave, we're talking about a wave that's now traveling at 2,000 meters per second. So, we've transitioned from sort of subsonic flows to now supersonic flows with shock waves and things like that. So, this concept of using detonation versus deflagration has the potential of increasing the efficiency by 5%, which is, a huge gain, because this technology not only has applications for power generation, but also in propulsion. In addition to my daily job, I'm one of NETL's STEM ambassadors. So it's been a lot of fun to do the STEM outreach stuff. I like coming up with cool little demonstrations that allow us to give examples of technology in an easily digestible manner. We did the Cub Scout tour here, and we gave them a tour of the laboratory, showed them these experiments where we're trying to solve some of the nation's hardest energy questions, right? And we did it in such a manner that the kids understood what was going on. All the kids had great questions, and in some cases stumped some of the scientists. It's really exciting to see when you do that, to see one of the kids get it. You virtually see the light bulb, the aha moment. A question from a kid may not be posed in a real sort of technical or scientific manner, but they're really asking the same kinds of questions that our peers are asking. So finding a way to answer their questions in a manner that they understand, that allow them to pull in from the environment that they're familiar with, is really exciting. One of the things that helps me is that I've had exposure to a lot of different areas of science and the world around me. And I try to compass a lot of those things into my everyday work, and I think that's helped me come up with creative solutions.